Ever wondered how mariners track other vessels and predict potential collisions on the high seas? Radar plotting. Well, in this video, I'm going to demonstrate a step-by-step process on how to plot a target by obtaining its CPA, TCPA, true speed, and true course manually. Radar or radio detection and ranging is a nav equipment used to track targets. When target has been spotted at the first minute, obtain its information, bearing, and range. Your first observation will be labeled as R, then with 6 minutes or any divisible by 6 time interval, make an observation again, then be labeled as M. And as with your first and second observation, prepare your plotting tools, and without further delay, let's get into it. On our radar plotting sheet with our own vessel's information being our speed and bearing, then target's information. First observation at 11:46 with 6 minutes interval, and while 11:52 is our second observation. Using our compass leg to scale the range, triangle placed at CCRP and pointing to the bearing of our first observation. And now we have our point R. Next is our second observation. With the same process of scaling the range and pinpointing the bearing, there we got our point M. By connecting R and M, you can draw a line, namely RML or relative motion line. Draw a perpendicular line to CCRP to form 90 degrees, and that will be your CPA or closest point of approach. Solve for relative speed by getting the measurement from point R to point M and then convert into 60 minutes or 1 hour reading. Simplify. That's how you get the relative speed. Next will be from point M to CPA. The remaining distance until CPA. Scale it, and the reading convert again into 60 minutes or 1 hour reading by referencing the relative speed. How much time can we get in 4.5 nautical miles? Cross multiply as what we usually do. Same process of simplification, and that's how you get the TCPA or time of closest point of approach. Back to our CCRP, measurement of the perpendicular line determines our CP. Next will be the application of our own information, namely point E. But first, let us convert our speed into 6 minutes reading to compensate point R and M. You can follow the conversion shown or simply divide your speed with 10. Scale the result, which is 1.3. Using triangle, plot your bearing from point R and apply the 1.3 range. There you can have your point E. Connect points R, E, and M. A and R represents our, while E and M represents them. Bring out your two triangles, move and slide to our CCRP to determine points E and M or target's true course by drawing a straight line. Measure point E and M by the leg and scale it, convert into 1 hour reading, again with a simplification, or simply multiply by 10. That's how you get target's true speed. And there you have it. That's how mariners predict potential collisions on the high seas. Mastering radar plotting is a key to professional seamanship, vital for safe navigation. And that's it for today's video. I hope you learned a thing or two. Stay tuned for more learnings here in our cadets workplace.